All right, this is lesson 6, and we're going to start the tests. All right, we're going to start the integral test and the p-series test, and this is testing for convergence. And I have if f is positive and continuous and decreasing for x greater than or equal to 1. So you have to have a decreasing series. It has to be continuous. So if there's any place where it's not continuous, this is not the test to use. All right, we say f of x is equal to the series. And basically, if it's going from 1 to infinity, we'll evaluate the integral. If the integral converges or diverges, that's what the series does. Plain and simple. And if you remember how to do these integrals, when it's infinity up here, you have a limit. So let's do one. Easy one. Okay, it says apply the integral test to the series. I got a series of n over n squared plus 1 from n going from 1 to infinity. So I'm going to change that, or I'm going to see this thing is the same as this. Okay? And I got to put a d, that's what I'm erasing, dx. All right? So now, when I go to do this integral, I'm going to do it all with the blue here. All right? It's going to be the limit as a approaches infinity, and we're going to have from 1 to a, and we're going to have x over x squared plus 1 dx. If you remember how to do this, I know it's been a while, I'm going to set u equal to x squared plus 1, and that means du is 2 dx's, 2x dx, I'm sorry. So that is going to put a 2 here and a 1/2 on the outside. So we're going to get 1/2, the limit, as a approaches infinity of, looks like 1 to a du over u, I guess. All right? So what we're going to do here, or u to the -1, if you will, and what we're going to look at is we're going to take the integral, and we're going to get 1/2 the limit as a goes to infinity, and it's going to be the natural log of u, natural log of u, which is going to be x squared plus 1, and that's that evaluated at a and 1. Well, if I throw infinity in here, this guy's getting ridiculously large. All right, so this guy is going to infinity, which means it diverges, which then goes all the way back to here and means that, whoa, Nelly, this diverges. Okay? That's how the integral test goes. Do the integral of it and see if it converges or diverges. Now, it has to be continuous. Okay? Has to be a continuous function. No -1, no something here won't make it discontinuous. It wouldn't work. This test would not work on something that looks like this. It wouldn't, because that's discontinuous at 0. Okay? All right. Another one? Sure. Sure. See how I can't get 0 in the denominator? All right, so this is going to be equal to, let's go limit as a goes to infinity of a, 1 to a, and let's go 1 over n squared plus 1 dn. I don't know if you recognize this one, okay, but this one is your favorite, maybe. I don't know. Well, this guy is your arctan of n. Okay, it could have been x, doesn't matter. Arctan of n at a and 1. Well, when I go to infinity, the limit as a goes to infinity of arctan of a, I guess. This guy, if you remember the graph, arctan goes like that, and it approaches pi over 2. Well, the arctan of 1 is pi over 4. So you subtract them by the fundamental theorem of calculus. You subtract, and you get pi over 4 as your answer. So that one does converge. Okay? So we have convergent and divergent series. Now let's go to the p-series. P-test. If it's n to a power on the bottom, that's your p. Okay? And it converges if p is greater than 1. However, if it equals 1 here, we call it a harmonic series. All harmonic series diverge. Okay? So now, and remember there's 1. Okay? So over here, here's the general format of a harmonic series. It's 1 over an plus b. So if I had 1 over, and you'll see it, 1 over like 3n plus 5, okay, that's diverging, okay? So let's take a look, and here's some examples. If I had 1 over n square roots of n, that's really, we could change that to 1 over the 3 halves, n to 3 halves. Well, p is 3 halves, which is greater than 1, so it converges. It doesn't tell you what it converges to, but it converges. Example, here's another example. Ooh, what's going on with the bottom? Well, it's the 4th root of n squared. Okay, if this is the first term, second term, third term, fourth term. So that means the 4th root of n squared means we're at n equals a half. Half is less than 1, therefore it diverges. By the way, 3 dots is therefore. I don't know if you knew that or not. So there's a divergent p-series. Now I got some homework for you. On page 622, I want you to do 1 through 9. We'll do a few in class. We'll do like 7 or 8 problems in class, but this is what I want you to start with. 1 through 9, and you're going to tell me if it converges or diverges. Okay? So you looked at 2 things, just to recap. You looked at the p-series, and you looked at the integral test. Okay? Integral, you just take the integral. P-series, you look at the p. If it's less than 1, it diverges. Greater than 1, it converges. Equals 1, we're in trouble. Okay? So that's where we're at. Greater than 1, converge. Less than 1, diverge. Thank you very much. This is lesson 6, and we have just tests and tests and tests to learn, and they will be this quick. All right? Thanks.